Geography 201, Chapter 3. This is kind of part 3, 3.5. So hopefully you've watched that video about heat waves from 1995. And a couple things I wanted to point out. First of all, I'm not sure if many of you were aware of that year. Most of you I know are younger than that. But that was a very hot year. I was actually living in St. Louis, Missouri, which is about 300 miles south of here. And it was so hot that year in St. Louis. I remember driving home and seeing the bank thermometer saying 110. They were saying things on the radio like, don't go outside because you will die. But one of the things that happens with high humidity and high heat exhaustion that I talked about, right? The body starts to cook. And if you have any kind of health condition, it can make it worse. If you are pregnant and you start to have heat exhaustion, one thing it will do is the body will go into early labor, because having a child, carrying a child, is a very stressful thing on your body. And if your body is in danger of dying, it will try to end the pregnancy. And my first wife, actually, I have a daughter who was born in 1995, and she was born almost early because of that. My ex-wife went into premature labor because of the heat that year. But this is not an uncommon occurrence, right? And I don't know, people are kind of shocked. I mean, the idea of having refrigerated trucks outside the morgue to hold the bodies, that hasn't happened, well, actually since now with COVID. So heat can be a very damaging killer. But let's talk about humidity some more. So there's a lot of contradicting terms. People aren't always clear when they mean humidity. So we have two terms that we deal with in this class scientifically: relative and specific. So specific humidity is the actual water vapor content in the air. So the air is holding so much water per kilogram, right? Now, here's the thing. Air can hold different amounts of water vapor based on temperature. Colder air can hold less water. Warmer air can hold more water, because as air gets warm, it expands. It has more capacity. So you have this idea of relative humidity. In other words, how much water is the air holding based on how much could it hold, because that can change. So here's a graph that just shows you the temperature. As the temperature drops, right, the specific humidity of the air may stay the same. It may be holding the same actual amount or grams of water vapor per kilogram of air. But as it gets colder, it can't hold as much. So temperature and relative humidity are always opposite. If temperature drops, relative humidity increases. So let me show you this next graph. It kind of makes it more relatable. This is on a summer day at 4 p.m., midnight, and 4 a.m. And this is the amount of water vapor in the air. Let's just say whatever this number is. But you notice it stays constant. So the amount of water vapor in the air does not change. But at 4 o'clock in the afternoon, the sun beats down and the air is the warmest it'll be all day. So let's just say that it's 85 degrees. And the air's capacity has expanded. So even though this water vapor here is the same, it could hold 80% more. So the relative humidity at 4 o'clock is only 20%. The air is only holding 20% of what it could. As the sun goes down and it begins to cool off, so does the capacity. As the air cools, the capacity shrinks, and by midnight, the air is holding half of what it could hold. It hasn't changed how much, but the humidity as a relative number has increased. And so at 4 o'clock in the morning, when the air is the coldest, right before sunrise, now the air is said to be saturated. It can't hold any more water. So it's 100% saturated. Now here's an interesting fact, right? When does that happen? They call it the dew point. So if the dew point is 55 degrees, that means that when the air hits 55 degrees, it'll be full of water. It can't hold any more water. So what happens if it goes below the dew point? Any water, almost like a sponge, will get wrung out. That's when you get dew, that kind of light level of water in the morning. Usually right before the sun comes up, it's the coldest. Let me go back to that image. And water starts to precipitate out, starts to basically form dew on leaves and plants. And as the air warms back up, it evaporates because now it has more space. Now, Dry air has a low dew point because, to go back to that image, if this bubble of water is smaller, this temperature capacity can be smaller. So in other words, the colder the air is, the drier it is, can be. Warm air has a high dew point because if the air is big and warm, go back to that image one more time, right? In order for this to be full, you'd have to have a lot of water. So it's a high dew point. Generally speaking, temperatures and dew points and humidity at the equator, tropical air has the highest relative humidity. It's warm, so we can hold a lot of water, but we have rainforest and oceans, so we have a lot of moisture in the air. As you move north or south, the humidity begins to drop, right? There's less water and there's less heat. But here's the thing, as we get closer to the poles, humidity increases. And that's because at the South Pole or the North Pole, the air is so cold. So at the South Pole, the temperature can be negative 40 degrees. It is so cold that the amount of water vapor it can hold is so small that any amount will fill it up. So much so that if you're in a really cold at the South Pole, if you're out in the South Pole and you breathe out, sometimes the moisture in your breath will actually turn to dust and snow. It's actually a fun science trick. If the air temperature is below 10 degrees, negative 10 degrees, and you throw a coffee cup worth of hot water into the air, it'll turn right to snow for that very reason. This map just shows you various dew points. This was taken May 1st. The darker the green, the higher the dew point. And what this is showing you, this is warm, moist air. And no surprise, over Florida, New Orleans, the Gulf Coast. The warmest, wettest air in this country tends to be in this area. Why? Well, it's closer, it's south, so it's very warm. Plus you have the Gulf of Mexico, warm water, so lots of water. As you go further north or away from the water, it gets even drier. And the driest air tends to be in the west coast because A, you have the mountains, elevation, you're far away from the oceans, and you're cold. And as we'll learn right here, whenever you see a switch in dew from warm, moist to cold, dry, and a quick shift, notice how close together these lines are versus a gradual shift, you will often see very strong, severe weather along these points. All right, I'm going to pause right here. We'll move on to section 3.3 in just a moment. We'll be right back.